Today topic we are going to see about temperature measuring instrument using thermocouple. So far we have gone through so many temperature measuring instruments like RTD, thermistor, then we have pyrometer, that is the non-contact one. The another one is for thermocouple. So the thermocouple, it's a device used for measuring temperature. So more than 700 degree you want to measure, then we can go for thermocouple, and all the industry they are measuring the temperature using thermocouple alone. Thermocouple, which is nothing but it's a comprising of two metals joined together to form two junctions, and one is connected to which temperatures you are going to measure, that is nothing but hot or measuring junction. The other one is connected to the body of the known temperature, that is cold. So when two dissimilar metal, when you are connected, it will create two junctions. One junction we used to call hot, the other one is called as a reference junction. So this is how the thermocouple is made of, and the thermocouple measure the unknown temperature of the body with reference to known temperature of the other body. So generally in thermoelectrical laws, there are three laws we have. One is Seebeck effect, another one is Peltier effect, then we have Thomson effect. What is Seebeck effect? Seebeck effect, which is nothing but two different metals are joined together at two different junctions. There will be an EMF generated. The EMF generated is different for different combinations of the metal, and most of the cases the EMF suggested by Thomson effect is very small and it can neglected by making proper selection of material. The Peltier effect play a prominent role in the working principle of thermocouple. That is nothing but Peltier effect means same if two dissimilar metal joined together, and the EMF will be generated the circuit due to the different temperature of the junctions of the circuit. That means the EMF is generated through the conductor. You can't able to measure. Peltier effect. Then Thomson effect in the sense, here also the same thing, that is two dissimilar metal are joined to form two different junction. The potential axis within the circuit due to temperature gradient along the entire length of the conductor within the circuit. So that is also not, we can't able to measure. So the people we are using the thermocouple, the basic principle is about Seebeck effect. So they used to call it as an two different conductors are positive leg and negative leg, and here the combined position of those two are, it's like an hot junction. The another one we used to call it as an cold junction. So here this is the one is the measuring one, and this is the one as a reference one. This is how the working principle, the basic principle of Seebeck effect is working on the thermocouple. So in thermocouple, whatever the material we are going to use is very, very important. There are so many different types of materials we have in thermocouple. The combination is type E, J, K and N, and people used to go K and J only. E is a combination of chromal with constantine. Constantine, which is nothing but it's a combination of nickel with copper, and chromal means it's a combination of nickel and chromium. Then for type J, which is nothing but constant and iron, and the temperature range is up to 1400 degrees centigrade, Fahrenheit we can able to measure. Then for type K, it is chromal with aluminum. Aluminum, it's a combination of nickel, aluminium and silver. Then silicon. Type N is a combination of nickel and chromium. Then we have a combination of chromium, nickel and silicon. Then according to these type of materials, the characteristics has been taken, and here we can see the graph between temperature versus millivolt. We are having 4 graphs over there. The first one is J type, then K type, J type, T type and E type. So based on the performance characteristics, the people used to go for the material choice. The temperature range is up to 1800, and the linearity is very poor and sensitivity also very poor. Then for comes to this thermocouple. Here the thermocouple measurement, they used to have thermoelectric EMF E, which is equal to A into del theta plus B into del theta the whole square. So del theta, which is nothing but difference in temperature between two junctions. So where A and B are constant, so finally you will have del theta, which is E by A. So up to 1400 degrees centigrade we can able to measure. And one more thing is, when you are talking about this thermocouple, to measuring the temperature using thermocouple, you can't just connect the thermocouple to the measuring system. Via voltmeter we can able to get the value. Here you can just look at, there are two conductor, blue and red. So one is made up of like either we can go copper or nickel, or else they used to go for aluminum, copper nickel alloy. So the type of material depends on the type of material, the type of thermocouple they used to go for. So K, T, J and E, it's a different combinations of metals they have used. So here when two dissimilar metals are kept in one point, here there is an hard junction, that is the measuring. So here which there will be an EMF generated. I want to see the EMF generated. And one more thing is, here the reference junction, which is also called as a cold junction. So using that you can able to measure the value across this voltmeter. So this is how your thermocouple is working. Just look at the diagram, how the thermocouple and it's working. You can just go through this. There are two dissimilar metals, metal 1 and metal 2, and we have a junction. Whatever the EMF is created, that will be monitored through this particular meter. So by joining two dissimilar metal, two junctions are formed. Actually this one I have taken from the Engineers Academy, and these like thermocouple work on three basic effects: Seebeck, Peltier as well as Thomson effect. So I already explained to you what is the difference between the Seebeck as well as Peltier and these things, Thomson effect. And here you can just look at Seebeck. This EMF is generated two junction, the amount of EMF generated at different combinations of metal, that is what Seebeck. Then comes to your Peltier effect. Here the EMF will be generated within the circuit. So that is what Peltier effect talks about, within the circuit. So it is not the EMF generated in the junction point. So due to different temperature of the two junctions in the circuit. Then third one is about Thomson effect. Thomson effect, which is nothing but the EMF is exist in the circuit due to temperature gradient along the entire length of the circuit. That is what Thomson effect. And the EMF induced is very small, so it is neglectable. You can't able to measure with a proper selection of material. That is the reason they are stick on to Seebeck effect, from which we can able to measure the voltage, that is your output voltage. And the output of thermocouple is normally it's like a millivolt, so you can't able to measure the voltage. So output of this voltage will be directly connected to the amplifier to increasing the millivolt level. That is how the thermocouple is working. And the metals used here is constantine as well as iron. So this thermocouple is used to measure for high temperature in power plant as well as any industry. If you are going for high temperature measurement, we can go for thermocouple measurement. So this is how the voltage or current obtained from the thermocouple circuit gives the value of unknown temperature.